is x, the codomain is f of x. That is what we are trying to see. So now we are going to
This call is now being recorded.
we want to prove it and see whether it is going to be 1 to 1. So we start by stating this: f of x1 is equal to f of x2. Then we know f of x1 to be x1 all squared is equal to f of x is x2 all squared. So you find the square root of both sides. So when you find square root, this will become x1 is equal to plus or minus x2. So what happens now is that this implies that x1 is either equal to x2 or x1 is equal to negative x2. And when you have something like this, they are trying to tell you that the function maps to two elements in there. So let's say we have x and then y, and you have x squared. So you have 2 and negative 2. When you find 4, you know f of x is equal to x squared. When you find f of 2, you are going to get 4. And you find for f of negative 2, it's also going to be 4. Meaning that this is mapping to this. This is also mapping to this. And because of this particular thing we are seeing here, this function is not going to be 1 to 1. Please, are we okay?
Yeah.
No, please. Yes, please.
So So that is the explanation I've done. So in the example, they are saying that the function f of x is 1 to 1 as we did earlier. Since if x1 is not equal to x2, then f of x1 is not equal to f of x2. So we did the other way and we had it to be correct. On the other hand, when you check for g of x to be x squared, it is not going to be 1 to 1, because when we use the values negative 2 and 2, we realize that the image is going to be 4, and both 2 and negative 2 will map to the same element in the codomain, which will make it not 1 to 1. So let's note that 1 to 1 functions are functions where element in the domain maps to only one and only one element in the codomain. So that is the examples that has been done. Let's take note. So this one too, for the g of x equal to x squared, as I was saying, the negative 2 and the 2, you realize that it's mapping to the same element in the codomain. And because of that, it is not going to make it 1 to 1, but a different type of function, which is going to be many to 1. Yes, but in this course, we are going to focus on 1 to 1 functions. The other types of functions will not be looked at, so let's kindly take note. So now we will be going to the graph of 1 to 1 functions. So we are saying that if f, so f is the function, if f is 1 to 1. So now we've established that 1 to 1 functions are functions in which each element in the domain maps to one and only one element in the codomain. So now if we are saying that an f is 1 to 1, then no 2 points, that is x1, y1, x2, y2, have the same y values. Thus, no horizontal line cuts the graph of the equation y is equal to f of x more than once. So I want to do a, okay, there's a quick illustration here. So we are going to look at the graphs. So it says compare the graphs of the function f of x is equal to x and f of x is equal to x squared. So the one on your left is the function f of x is equal to x, and the one on your right is the function f of x equals to x squared. So the first one is a linear graph. The second one is a quadratic graph. Quadratic, we know that it is of the form f of x is equal to ax squared plus bx plus c. And we know for a linear graph or a linear equation, it's of the form mx plus c. So when we look at the first side, the linear graph, we realize that if you plot any x, it will have a particular y value. And when you want to check using the graphical method whether a function is one-to-one, you perform the horizontal line test. This is when you draw a horizontal line to cut the 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 equation. So what happens is that when the line cuts only one point, like what we have at the left hand side, it's supposed to cut only one point of the graph, then it makes it one-to-one. So if you look at the one on your right hand side, you realize that when we do the horizontal line through it, it cuts 2 points on the graph. That is x1 and then x2. And because it is cutting 2 points on the graph, it is making it not one-to-one. So we can conclude that all linear functions are one-to-one, and most quadratic functions are not one-to-one. Yes. Or let's say all, because at the end of the day, you get the graph cutting two sides, and which will not make it one-to-one. So when you have a graph and you are being asked to determine whether it is one-to-one, there is a test that you are supposed to perform, and that is called the horizontal line test. So after sketching your graph, you draw a horizontal line through any part of it, and when it cuts only one point on the graph at once, then it is one-to-one. But when it cuts more than 1 point on the graph, you conclude that it is not one-to-one. So horizontal line test, a graph passes the horizontal line test if each horizontal line cuts the graph at most once. At most once, yes. So that is about the horizontal line test. So these are some examples to determine if f is one-to-one using the graphical method. So a function f is one-to-one if the graph y is equal to f of x passes the horizontal line test. And to explain how it looks like, so we have an example: y is equal to x squared minus x cubed plus 10x minus 5. So after sketching this particular graph, you realize that the horizontal line is cutting more than 1 point at a time. It's cutting more than 1 point at a time. So this particular graph is not one-to-one, or this particular function is not one-to-one. Let's look at the one on our right hand side, which is y is equal to root of 4x plus 1. You realize that when you sketch this particular function and you draw the horizontal line through it, the line will pass through only 1 point, and this will make it one-to-one. And this will make it one-to-one. So if you notice the second side, that is root 4x plus 1, it is a linear function. It's a linear function. So linear functions, linear, but the second part is a polynomial with degree 3. So this, it will cut more than 1 point, and this will make it not. So let's look at inverse functions. Let's look at inverse functions. So for inverse functions, it is that we have a function f of x, and remember that the function f should be one-to-one. If the function is not 1, we cannot find the inverse. We can find the inverse. I want a function which is 1 to 1 with a domain A and range B. As we stated, the domain A and the domain, I will illustrate it very soon, don't worry. We can define an inverse. So if you have a function f of x, the inverse will be f inverse of x with domain B, and the rule will be that. So let me illustrate everything I'm saying here so that it doesn't sound clumsy. So we are saying that we have a function f of x is equal to y. Okay. So now we want to find the inverse of this particular function. So what do? You find f inverse of both sides. And you find f inverse of both sides, you will have this. Which means that now you have x to be equal to f of y. So which implies that the function f of x is equal to y. Its inverse is x is equal to f of y. So if you have a function f of x, we are saying that the inverse, you can write it as f inverse of x. That is all that we are trying to see. And so we have, let me use the domain, codomain, the illustration. We have x and y. So the rule of the mapping is f. So we have a and b, c and d. So what we are trying to say is x now is the domain, and y now is the range. Okay, so for this particular one, in this case, when we want to find the inverse will be the opposite side. So in this case, the f inverse would become, y now becomes the domain and x becomes the codomain when it is inverse. So it is going to be of this form. I've cleaned this. So if you are finding inverse, which is f inverse, now y becomes the domain and x becomes your range. Yes, so that is it about. But we will solve examples so you understand it better.
Please, are you okay? Any question? If you have any question, you can ask Madam, please.
Madam Again, you're welcome. Yeah, it's nice hearing from you.
Thank you. I'm driving. I went to Accra, so I'm driving. So I've joined. I'm
Okay,
here.
safe journey, safe
So
journey,
we are getting the understanding. She should keep it up.
safe
Okay, so
journey.
if you have any question, you can ask her, please.
So we would continue solving some examples. We are saying that if f of x is equal to x cubed plus 1, use the equivalence of equation given above, find f inverse of 9 and then f inverse of 29. So earlier I stated that you can, the equivalence equation we are talking about is what is at the beginning. So if f of x is equal to y, you find inverse of both sides and it will change, and then we would have x to be y to be. So we are saying f of x is equal to y. If you find inverse of both sides, you get x is equal to f of y. So that is what we want to do. And then we want to, after getting your inverse, wherever you see the value, you put 9 there. So let's try and solve it and see how it's going to be. Let's try and solve it together. So we have f of x to be equal to x cubed plus 1. So we want to find the inverse of this particular function. So what we are going to do is,
Hello, madam.
yes, hello, I'm listening.
Please, please, can you write the x? It looks like y.
Oh, okay, sorry. Yes. So f of x is equal to x cubed plus 1. So we want to find the inverse of this function. So what we are going to do is that we can rewrite f of x to be equal to y, x cubed plus 1. Do we agree?
Yes.
Perfectly. Let's proceed.
Yes. Yes, we agree.
So after getting this, the next thing you are going to do is that you are going to interchange the positions of x and y. So wherever you see x, you put y there. Wherever you see y, you put x there. So this, wherever we see x, y, we put x there. Wherever we see x, we put y there. And this is what we are going to get. So after getting this, what you do next is you make y the subject. You make y the subject. So we move x to the 1 to the other side. So we are going to get x minus 1. Then find the cubic root of both sides. So this side you are going to get y is equal to the cubic root x minus 1. And remember that your question was given to you in f of x and not y. So when you are done finding your inverse, you will come and say that f inverse of x is this. Please, are you okay? So after getting this, the next thing they are asking us to do is to find f inverse of 9. So what will be f inverse of 9? You are doing it for me. F inverse of 9. So wherever you
That's
see
true.
now, that is
2.
2. Okay. So, and the next one is asking us to find f inverse of 28. What are we getting for that one too?
That one's 3.
3.
3. That's very good. So let's try the next one. So it says that let's read something. Note that the domain of f inverse equals to the range of f, and the range of f inverse equals to the domain. So now we found 4. We had f of x. F of, we had f of we had f of x to be
Mr.
equal to
Jackson,
x.
Mr. Jackson,
Check
your
my
mic is
Biana
on.
down. Mikey Jackson, be careful.
Okay. And we had f of x to be equal to x cubed plus 1. And we found the inverse of f of x to be the cubic root of x. Is it x minus 1? Yes. Now I want us to quickly do something. Let's find for the inverse of that inverse. I want you to see something. We want to find the inverse of what the inverse we just found. You realize something. Remember this particular function. Let's keep it somewhere. So state f of x is equal to x cubed plus 1. We will see something quickly. So
Madam,
yes,
please, why is f of s inverse of 9 is 2 and but the other one is 3? I don't understand it.
I don't get what you're saying.
Said why F inverse of 9 is 3.
Okay,
It's
so
2
this is
and the
what
other
we
one is
said you get the cubic root of x minus 1, right? And the question is asking us to find f inverse of 9. Okay, so you have the equation. So this is what we had. Wherever you see x, you just put 9 there. So this is how you do it. 9 minus 1, 3. And the cubic root of 8 is 2. Please, is it okay?
okay.
Okay. And the next one was 28, if I'm right. So we have 28. So wherever you see x, you put 28 there. 28 minus 1. So you have 27. And the cubic root of 27 is what?
3.
3. So that is how we did it.
Okay, thank you.
You're welcome. So I want us to find the inverse of f inverse of x, which is this. So again, we will state that y should be equal to the f inverse so that it will be easy to solve. So now y becomes equal to x minus 1, the cubic root. And I said that if you want to find the inverse, wherever you interchange the positions of x and y. So wherever you see y, you put x there. And then wherever you see x, you put y there. And then we want to make y the subject. So it becomes x cubed is equal to y minus 1. And what to make y the subject, you have y is equal to, you are moving the 1 to the left hand side. So x cubed plus 1. Is this particular equation familiar?
Yes.
Yes, that's the
So
initial one we use
The
to find the F
that's
inverse.
the initial one we did. Very good. So what we are trying to establish is that if you have a function f of x and you find for the inverse, which is f inverse of x, that inverse, the inverse of the inverse is the function. F of x, which is x cubed plus 1, to be the cubic root of x minus 1. Now, if you want to find for that inverse of the inverse you found, it will give you back f of x. That is what we did here. So at the end of the day, the inverse of that inverse will give you back your function, which is this. Please, are we okay? So that was what I was trying to establish using the um, pictorial view, the domain codomain, the mapping thing, so that when you have the domain x moving into the codomain y with the rule to be f, if you move it the other way around, this time the y, which was the codomain, now becomes the domain when it is for inverse, and the x now becomes the codomain for the inverse. So let's remember that. So I'll give you, see if there's a question to try. So you want to try this one. You are doing it to yourself, and yet you tell me the answer. Let g of x be equal to the root of 4x plus 4. What is the domain of g? So how do we find domain of a function? Any idea? Anyone to tell me how to find the domain of a function? What does it mean when we say the domain of a function? Anyone to try?
Is a set of all values that makes the function defined.
Okay, that's
So
very good. Okay, continue.
so with the function g of x is equal to the root of 4x plus 1. So the value that you substitute into x, that will make the function undefined. I think that's not part of the domain. So the values that you insert into x, that will make the function defined is the domain.
Okay, that is good. So the sets of elements or values which will make the function g of x defined. And we know that we cannot have the square root of a negative number. So if you want to find the domain of g of x, it is going to be 4x plus 4 greater than or
So,
equal
so
to
at their
0.
level, they cannot find the square root of a negative number.
Yes.
For what we are doing, we are in the real plane,
Yeah.
so we cannot find the square root of a negative number. But when we get to the complex plane, we can do that. But for now, we cannot find. Please.
Okay. Thank you, Doc. So please, what will be the domain for this particular function, g of x? We are doing it too, so please do it and tell. What will be the domain?
Okay, I want to give it a try.
Okay, try.
So the domain be for all real numbers except x greater or equal to -1. Except
Okay, that
x
is
is greater than -1, yes.
sure. Please, do we agree?
Yeah, yes.
So, meaning that we would have all values in there except when x is greater than or equal to -1. So if you put -1 inside, are we sure? Yes. Is it going to be greater than or equal to -1?
So,
I
madam,
think
I said except is greater than -1.
equal to -1.
Greater
No, it should
than.
be
-1,
greater
yes.
than -1. Or except x is less than 0.
Okay, so let's solve it. So we have g of x to be equal to root of 4x plus 4. So if you want to find the domain, 4x plus 4 should be greater than or equal to 0. And then we can factorize 4 out to be let it's x plus 1 greater than or equal to 0. So 4 is not, yeah, let's focus the x part, x plus 1 greater than or equal to 0. So what happens to the sign? Will it change or it remains like that?
It
It
remains like that.
remains.
It's remaining. Just transpose it to the other side.
So meaning that x is greater than or equal to -1. So our domain g of x is equal to x is such that x belongs to all real numbers except x greater than or equal to -1. So that is our domain.
Hey, madam, please look at it again.
Hello, madam.
It's not
Madam, please look at it again. The domain is s greater than or equal to -1. It
-1.
cannot be less than -1, but anything greater than 1
Yes.
should be fine. So it should be s greater than or equal to -1.
so our domain is x greater than or equal to negative.
Yeah, so x such that s is greater than or equal to -1.
Okay, thank you very much.
So they can choose numbers. When s equal to 0, they will get 4 and it works. 0 is greater than -1. You can choose 10.
Yeah.
When it's 10, we have 40 plus 4, which is 44. And you can find the root of that. So it should be greater than or equal to -1. Thank you. I'm driving, I'm going, so I'm online.
So the next thing is you want to find so you find G.
Madam, Madam Charity.
Yes, please.
When you were solving, I could see that immediately you wrote square root of 4x plus 4. You eliminated the square root and then started solving it. And then my question is, where did the square root pass? Thank
Okay,
you.
so the values of s that will make the function defined. So we are looking at the function under the square roots, the value of the function under the square root. We know that if we cannot find the square root of negative number, so we want to find the
Inside the
value. So the focus is on the
inside,
function under the square roots, not for that. Okay, so I think she can explain it better. Let me continue my journey.
madam, inside the square root or under the square root.
So that is why when we were solving, we used the inequality greater than or equal to 0. Because under the square root, we cannot have a negative, so the function should be greater than 0 or equal to 0. Because if you have any number greater than or equal to 0 and you put it in your g of x, it is going to be defined. But if you have anything less than 0, it won't be defined. That is why we use that inequality to symbolize that whenever there is a square root, it's implying we won't have any negative values. So we are looking at it from the positive side. Please, is it okay?
But madam, -1 will work. Oh.
-1.
Yes.
So yes, that is why.
That's why we said
F is
equal to
greater or
-1.
equal to -1. So
Greater than or
-1 is
equal
flat.
to -1.
So -1 is flat.
So what happens is whatever is under the square, we use the inequality greater than or equal to 0. So after solving, you will get x is greater than or equal to -1. So that becomes the domain. Please, is it clear?
Madam, can I help?
Okay.
Yes, so when we solve our domain or what we had as our answer is x greater or equals to -1, it means that when we put -1 into the function, we'll get a value under the square root that would make the function defined. Aside that, any other value cannot go. Just that we should make sure that when we put any value into the function that is under the square root, it should not give us a negative value. So even if you substitute -1 into it, it will give us a value that will not be negative.
So when you
And that
substitute
is why,
-1, it will give you 0. That's what she said. The beginning should be greater or equal to 0.
yes.
So please, are you okay? Okay. So please, let's.
So, madam, in conclusion, you have to get a number that will be 0 or upwards. It shouldn't be less than 0. That is negative numbers. Am I right?
Yes.
-1 is part, so you shouldn't take it from 0 upwards, but from -1 upwards.
Please, we are not talking about the. So the first instance, we are talking about the function under the square roots. Then after that, we solve for x. So the -1 we are talking about is for the s values. but the function altogether should be greater than 0. So the beginning, she said that the function 4x plus 4 should be greater than 0. Then after that, you have to solve for the value of x. So when she solved for x, she had -1 upwards. So x value should be greater or equal to -1, but the function itself should be 0 upwards. That should be the understanding.
We are still confused.
So
So
if she's
please,
so
can
Madam,
we find
confused, then
let's
maybe
continue.
she
Yeah,
can
madam, please
look
solve
at
it
it again.
again.
We
Maybe.
are we are okay.
Please
Hey,
say I am okay. Don't say we are okay. I am okay.
you are okay, not say
Okay.
I am okay.
Can you solve it
I
again?
personally am okay.
Please, you can look for another question. Madam, look for another question and solve it
I
with them.
personally am okay.
hello? Hello.
We are here. We are here. I think we did this under algebra, and the whole thing is okay.
The good thing is the person who taught you is still here. So I don't know why you are still struggling. So maybe she has to go back and revise. That's what you should do, please. Madam, just
Okay.
solve another question and we can continue because we are supposed to know this. And I taught them too. So please, let's continue.
So please since we found the domain, let's go on to find the inverse. Let's find g inverse of x. Please, you are doing it for g inverse of x. What are we getting?
Yeah, the g inverse of x is equal to x squared minus 4 all over 4.
Please, are you getting the same thing?
No, please, no.
Wow. Okay. So let's try to solve it quickly. So we have g of x to be equal to 4x plus 4. You want to find you change y is equal to 4x plus 4. And then whenever you see, you interchange the x and y positions. So you're going to get 4y plus 4. We want to make y the surface. So what you have to do first is you find the square of both sides. So you have x squared equal to 4y plus 4. Then you bring 4y. So you are shifting the 4 to the other side where x squared is. So you have x squared minus 4. You divide both sides by 4. You are going to get x squared minus 4 divided by 4. Are we getting this?
Yeah,
Yes.
that's one thing.
Okay. So now your gene inverse of x is equal to x squared minus 4 all over 4. Are we okay now? But someone said he didn't get this. Anyway. So let's find g inverse of 4. What are you getting? G inverse of 4.
3.
Okay. Are we all getting 3? Are we all
Yes,
getting
yes,
3?
Yes.
Okay.
Yes.
Now, so this question, let me ask, what would be the range of g inverse of 1? What would be the range of g inverse of 1? Remember that we found for the domain of g to be what? X is such that x belongs to x is greater than or equal to -1. That is for
Then
the domain of g
the,
of x. And now we are asking for the range of
the
g inverse of x. What will it be?
the range will be +or -2.
Madam, please. I will join later. I have to do something. I'm still driving. So you continue.
Okay.
Thank you very much.
Okay,
The,
please.
the range will be -1 and any positive value of up to infinity.
So this is what he's correct. You remember that I told you that when you have a function f of x, domain range. Now, when it is the inverse, the range of the function f of x will become the domain of f inverse of x. And then the do you get what I'm trying to say? It will just change, positions will change. So we are asking for the range of g inverse of x, which is equal to the domain of g of x. Is it okay? So it's going to be x greater or equal to -1. That is going to be the range of g inverse. Please, are we okay? Can I proceed?
Yes, please.
I'm trying to say that we said we found the domain of g of x to be x is such that x is greater than or equal to -1. Agreed.
Yes.
Agreed.
Yes.
Now,
Yes.
now it means that for range of the g inverse, it is the same as the domain of g of x. That is all that we are trying to say. And when you find the range of g inverse, it is the same as the domain of g inverse.
Madam, can you
It is
go to the board? Can you go to the board? Write them down. Let's see something so that we'll analyze it.
So what I'm trying to say is we found we asked for the range of g of x. The range is the same as, so this is for domain, and this is range. We are asking for range. They are all the same answer. They will give you the same answer. And when you have g of x, now when it is range, and you have g inverse when it is the domain, whatever you get is the same for both. That's what I'm trying to say. So g of x, the answer we had for the domain, is equal to g inverse of x, its range. That's all. So if you want to know the range of g inverse of x, it is the same as finding the domain of g of x. Please, is it clear?
Hello, madam.
Is it clear?
Please, what did we get for the range? What did we get for the range?
We didn't solve the range.
Okay. So I want
I'm
us to
just
solve it.
trying to establish something with you, that we solve for the domain of g of x, and we had x should be greater than or equal to -1. And the question is asking to find the range of the inverse of that function we found. And I'm saying that the range of the inverse is equal to the domain of the function.
Understood.
Okay. But madam,
Please, I'm listening.
the range, I thought the range of the g inverse of x, I was thinking they are the values that the x value you substitute into the inverse that will make the function defined.
Okay. So what are
Is
they?
that the case, or it means something else?
The x values are what?
Like
They are
when you
the
substitute into
range.
the inverse.
No, no. The range is the y values that will make the function defined. Oh.
Okay.
Yes, range is the y values. Domain is the x values.
Okay. The y values.
Yeah.
Okay. Thank you.
So here we want to find a formula for solving. Okay. Want to find a formula for solving.
So please, madam, I want to know the differences between range.
What?
Madam, my question.
Please, I can't hear you. You were saying
Madam,
something.
please, I want to
Okay.
ask you a question. I want to know the differences between. I want to
The
know the
range
difference between the
and
range and an inverse function.
the range and
Inverse
inverse.
and the inverse.
The range
Yes.
is the y values that will
This one, need to check.
Mr. W.
Let's continue.
Hello, madam.
I think microphone is muted or something.
And please, Mr. Thomas, please, can I hear your voice? Because your voice is too much.
Madam Charity, please, if you can hear us, we can hear you.
You want to hear my voice? Mr. Thomas.
Please, can you hear me now? Hello.
Yes.
Yes.
Of course, of course.
Someone muted me. That's why.
Doctors.
It was Doctor's
Please,
Watson.
let's confirm.
Doctor's muted you.
It's fine. Let's continue. So we have y is equal to f of x. So we are going to solve x in terms of y. It is what we were doing already, but this time they want to put it in steps. So you have a function f of x is equal to y, and then you switch the positions of x and y. But in this case, you find the inverse. So when you find the inverse, f will x, you switch the positions as stated there. So it is what we've been doing already. So if you have a function, when you interchange the positions, you are going to, when the positions of x and y, then you make y service there. And let us note that if you have a function and its inverse, it will give you the inverse. So we have a hashtag A, asterisk A and asterisk B. You realize that asterisk A is saying that f inverse of the function f of x is equal to x. Cases, whenever you do that, when you have a function and its inverse, it will give you whatever is inside. So if you have f of 2x at the end of be what you will get. So solve examples and then you see how it is going to be. So these ones, you do it for me, even though it is already here. So you do it yourself and then you compare. So we have f of x is equal to 2x plus 1 all over x minus 3. So first of all, let's quickly find f inverse of x. Let's quickly find f inverse of x. What are we getting? Quickly, what are we getting?
Three x plus 1 over x minus 2.
Okay, so that is what is down here. So let me go through the procedure. This one has been solved, so let's follow what they did. So first of all, you remember that I said you let y be equal to the f of x so that you solve it easily. So now y is equal to 2x plus 1 all over x minus 3. Then you cross multiply it. They cross multiply. So the y will now multiply the x minus 3. So after doing that, you want to make y the subject. So you group like terms. The y's will come to the same part and the only x's will go to the other part. You factorize this one, they didn't interchange the x and y values at the beginning. But if you change the x and y values at the beginning, when you factorize y out. But if you don't interchange x and y values at the beginning, when you factorize y out. When you get your final answer, then you interchange x and y. Anyways, they are correct. So you can decide to interchange the x and y positions at the beginning, or you solve everything. But when you solve, you make sure that this time you are going to make x the subject. When you are done, you get your answer. Then you make y, interchange x and y, and then y now becomes the answer. So anyhow you do it is still correct. So after finding our f inverse of x to be 3x plus 1 all over x minus 2. The b part is asking us to solve for f of f inverse of x and f inverse of f of x. So I will do the b and we will do the c. So I'm going back to the board. We are being asked to solve f inverse of x. This is what we are being asked to solve. So remember that the function, this one looks like this one. Do we agree? Do we agree? Hey, nobody is talking.
Yes, madam.
All right. So meaning that we are going to use the original function, which is equal to 2x plus 1 all over what? X minus 3. But look at it. In this case, you see when it is x, wherever we see it's x. But this case, it is f of x, f inverse of x. So now what we will do is that we will change it. So wherever we see, wherever we see x, we will now put f inverse of x there plus 1 all over wherever we see x, because the thing has changed, minus 3. Is it clear?
Yes, please.
Are we going somewhere?
Yeah, yeah, yeah.
All right.
Yes, please.
But know that we also solved for f inverse of x. So wherever you see f inverse of x, you have to replace that answer there. We had 3x plus 1 all over x minus 2 plus 1 all over 3x plus 1 all over x minus 2 minus 3. So this is what you have. So at this point, you apply, should I say board mass? Yes, board mass.
Or algebraic scale.
And then, yes, if you do it well, you get 7x over 7. If you do it very well, you are going to get 7x over 7. and 7 cancels 7, and then you are going to get x. And remember we stated that if you have a function and its inverse, you are going to get what? X. So this implies that the function and the inverse we got is correct. So in an exam, you can be asked that you have f of x to be a particular function. We have g, and they are saying that g of x is the inverse of that function. Prove that what you have is true. This is what you use. You use the f of f inverse of x. When you do your proof very well and then you get x, it implies that the function and the inverse are correct. But if you solve it and you don't get x, it implies that the function, the inverse that you have, it is not for that function. So when you solve and you don't get x, you conclude that maybe g of x is not the inverse of f of x. These are we okay? So this particular thing, we use it to check whether the function and the inverse are correct. If you solve and you're not going to get x, you should know that both are not, one is not the inverse of the other. So you conclude that it is not. So you should do the other way too. You can use this one to f inverse of f of x. That one too should also give you x. And that one, know that you are going to use this, the first one, it looks like this one. So what happens is, because you'll be using the inverse one, which is equal to 3x plus 1 all over x minus 2. But when it is f of x, what happens is that wherever you see x, you put f of x there, plus 1 all over f of x minus 2. And we know what f of x is, and you also apply, when you also solve it, you should also get x. Either way, give you an answer. That is all that we are trying to see. Please, are we okay on that? Please, are we okay?
I'm very okay.
Yes, madam.
All right. So when you solve the B, we did the B, the C I've guided you through. That one, if you do it very well, we are also going to get 7 over 7, which will give you x. So any of them is correct. So now we want to look at the graph of y is equal to f inverse of x. So this side is just reading and the properties. So let's follow. If there's any explanation, I'll do that. So we say that since the equation y of y is equal to f inverse of x is the same as x is equal to f of y, do we agree? Because one is the inverse of the other. We've stated two functions here. One is the inverse of the other. They are still the same. If you plot the function and its inverse, you are just going to get the same graphs. It won't change. Yes, the graphs of both equations are identical. To graph the equation x is equal to f of y, we note that this equation results from switching the rows of x and y in the equation y is equal to f of x, as you stated. This transformation of the equation results in the transformation of the graph, amounting to reflection in the line y is equal to x. So they are just bringing in the fact that reflection.
So, madam, the question.
Okay. Please
The first one, y is equal to f inverse. The first one, y is equal to f inverse of x. And the next one is the same as x is equal to f
we are
of
saying
y.
their graphs.
And
Their graphs are identical.
So x is equal x being equal to f of y. It is a range, right?
Yes.
Is it the range?
Yes.
So which means that on the graph, the range and the inverse function they are the same.
Not inverse function. The range is different from an inverse function. Inverse is like the opposite.
But
just understand that it's different. If you put it like that, you confuse yourself. If you put it like that, you confuse. I get what you are trying to say, but if you put it like that, you confuse yourself. Because in a case where it is not like that, you will start to have issues. That is why I'm saying that don't put it like that. Just understand what range is and what inverse is. That's all. Please, are you okay? All right. So that's the graph of y is equal to f inverse of it's a reflection of the graph y is equal to x in the line y is equal to y is equal to x, and vice versa. So the reflection of the point x1, y1 in the line y is equal to x is y1, x. So what happens in the inverse is that when you have a point x1, y1, when you find the inverse, the positions will change. So now your x part will become y1, your y part will become x1. That is all about inverse, the opposites. Therefore, if the point x1, y1 is equal to f of x. So it's just the opposite. So you realize that the coordinates, they are just changing positions. The ones which were y are now x. The ones which are x are now y. So that's about the graph. So a function is inverse. That is all that they are trying to establish. When you sketch it, it is identical. They don't change. They look the same. Yes, they are very the same because it is a function and it's inverse. Yeah. Properties of the graph y is equal to f inverse of x from y is equal to. So we want to look at some of the properties of such graphs. Say that if f, so we have two theorems here. If f is 1 to 1, we know what 1 to 1 functions are. And continuous functions. Continuous functions are telling us that if you have a function a point a, the function at that point should exist, and the limit of the function as it approaches that point should also exist. So we are saying that it should be 1 to 1 continuous function defined on an interval. Then its inverse, f inverse, is also 1 to 1. So if you have, what they are trying to say is, if you have a function f of x, and when you solve it is 1 to 1 continuous, it implies that its inverse too is 1 to 1 continuous. That's all. Thus f inverse of x has an inverse which has to be f of x. So if you have a function f of x, the inverse is f inverse of x. And if you have a function f inverse of x, its inverse is also f of x. So it's just the reversal of the other by the equivalence of equation given in the definition of inverse function. The next theorem says that if the function f is 1 to 1 differentiable function with inverse function. So different 1 to 1, we know what that means. Differentiable, it means that the function should be able to differentiate that function. Yes. So if you have 1 to 1 function which can be differentiated with inverse function f inverse, then we are saying that f prime, that is the derivative of f inverse at the point a, should not be equal to 0. So we are stating a formula here that if you want to find the derivative of the inverse function, then it is equal to, so you can note it down, what is at the bottom there. So if you want to find f inverse prime, it is equal to 1 over f prime of f inverse of a. We'll solve examples so you don't be bothered, don't be scared. we'll solve examples and we'll all be fine. So this is what we are saying. So let's go on to see if we have some. So this is the proof for the formula beneath. They want to prove that theorem, and it is also coming from the x is equal to f of y. So it is an implicit function. So you apply implicit differentiation to it, and when you solve, and you do it very well, you are going to get what they were talking, that formula, the f prime of f inverse of x. So it's a proof. So let's try and then take our time. They've given you the steps, so let's look at it carefully and then let's see how it works. So it says that geometrically, this means that a, so these are points A and f inverse of A is a point on the curve y is equal to f inverse of x. Then the point f inverse of A and A is a point on the curve y is equal to f of x. And the slope of the tangent to the curve y is equal to f of f inverse of x at that point is the reciprocal. So all these things, it is all that we've been talking about earlier. When you have a function, you interchange x and y positions. By this time, because you want to prove a formula, you go about the implicit differentiation form so that you will get that formula, and that is what we have here. Because now we are moving on to find the differential of the inverse. So after getting your inverse, you want to find the derivative of that inverse that we've gotten. So there is an example here. It says that the inverse of the function f of x is equal to x squared with reduced domain 0 to infinity is f inverse of x is equal to root of x. So I want us to quickly check something, whether the function and its inverse will give us x. Let's solve it, even though it has not been asked in the slides. So the function f of x is equal to x squared. Please, you are doing it for me. And f inverse is equal to root x. Solve it and see whether you are going to get x. Let's quickly solve it and see whether we are going to get x.
Yeah, you're going to get it.
Please, what are you? Okay, so this implies that the function f of x, the inverse is root x. Very correct. And the formula that they stated, we want to find the derivative of the inverse. So how do you find the derivative of the inverse? You can do it straight away without the formula. But the question precisely said use the formula above. Because if you are to find, let me come to the board. If we are to find the derivative straight away, we know that f of x was x squared, and they gave us the inverse to be root x. We can straight away find the inverse, the derivative. And you know this one, we can rewrite it as this. And find the derivative is going to be 1 over 2x minus 1 over 2. And this is the same as 1 over 2 root x. Do we agree?
Yes, please.
All right. But the question said we should use the formula. So because of that, we would go through the formula and then solve it. So the formula, we know that we have to find f prime. So f prime becomes, what will be f prime? Derivative of f of x.
2x.
2x. Madam, 2x.
2x. Very good. And now we will put it inside the equation. We already know what f inverse is. We know that it is root of x. So now we want to find f. I'm coming. We want to find f prime, and the formula is 1 over f prime f inverse of x. And we know that we have one. F prime was 2x. But remember that wherever you see 2x, it is 2f inverse of x. Are we okay? The
Madam, please
function
come
says that
again. Come again. Come again.
the function, let me clean this side. This thing, sorry, this thing is what? Inverse. This whole thing, why is my email? This whole thing is the same as x. And we know that f of x here is this. By this case, wherever you see x, you put f inverse there. That is what we did here. Is it clear? Is it clear?
No, no.
Madam,
Oh, madam.
Hey, this
Madam, is
thing
that
is,
a final answer?
yes,
it's not complicated though. I don't know why. I
Madam,
don't know why.
please,
So I'm saying that,
yes.
please let me continue. I'll explain. F inverse of x, we are saying is equal to root x. Now we are being asked to find f prime of f inverse of x. And we can represent the whole of this by x. Right? And we know that when we found f prime of x, we had 2x. But this time, wherever you see x, you put f inverse of x there. That's what I'm saying. So this time, f inverse of f prime of f inverse will become 2 of f inverse. Is it okay? It's the same. But this, the first part, it was x, so here was x. But the second part, you are using f inverse. Wherever you see it, you put f inverse there. Are we okay?
Yes,
So now
please.
we know that f inverse is root x. So you have 2 root x. And the formula said that f inverse prime should be 1. And we said it's going to be 2 root x. It is the same as you doing it directly without the formula, but they stated implicitly that, that we should use the formula. So that is why you had to go through the stages and all. So that is what they had. Let's look at it. So when you have the formula will require you to find f prime, because in the formula we don't have f prime. So you first of all find f prime, which is 2x. Then you come and use it to solve for f prime of f inverse. Then you come and just substitute it and you just get the answer. Yes. And the second one, let's look at how it was done. Let me see. Let's look at how it was done. It says that find the derivative of f inverse given. So this one, they are just asking you to find f inverse. They are just asking you to find f inverse. So us y is equal to x squared minus 7. I think they were asking for the derivative. Okay. So first of all, let's use the normal way to find for the derivative, the inverse of y. So it's going to be the derivative of y. So I want the derivative of y. You're doing it yourselves and you're telling me. What will be the derivative of y? What's y inverse?
Madam, y inverse is 2x.
Hello, please, not inverse, the derivative.
And I said that the derivative is
The
2x.
derivative is
2x.
the derivative is 2x.
Please take your time. I'm asking. What is the inverse of y?
Square root of x plus 7.
Someone was talking. Hello. Hello.
Hello.
Yeah.
Hello.
Yes. Think I
Hello.
can hear you.
Square root of x plus 7.
Very good. Now let's find the. So now we know the inverse to be square root of x plus 7. Now let's find the derivative of y. What is the derivative of y?
2x.
Madam, the derivative is
X.
2x.
2x. Now let's find for y prime of y inverse of x. What will be y prime of y inverse of x? Please, what are we getting?
2
Madam, please,
square
I
root
have
x plus
2
7.
multiplying root x plus 7.
X plus 7. Very good. So now what is f? What is y inverse prime? Y inverse prime. That is the derivative of the inverse. What are we getting?
Two x.
No.
1 over 2 root x plus 7.
1 over
Exactly.
2 x plus 7. Very good. So it is just stepwise. You see, the first example, if you notice, we were given the inverse of the function. But this one, they didn't give us the inverse of the function. So you have to find the inverse of the function, one. The second thing, you have to also find the derivative of the function you are given in the question, that is y. And the third one, you find the derivative of y inverse of x. And then you come and use the formula and just you substitute your values and you are done. But if the
Madam,
question doesn't, yes.
Madam, please, I want to ask something.
Okay.
You see the formula 1 on f prime multiplying the f inverse of x. That
Okay.
formula, it represents what? What does it
It
represent?
represents a person. I don't get it.
Kada wa bɛsɛ ɔkyerɛ sɛ yɛde solve deɛ yɛde solve
Yeah,
mu
they
deɛ
said
yi.
that.
It's easier to solve the derivative of the inverse. Yeah, the top derivative of inverse now. We are using it to solve the derivative.
Madam, so can I come in a little?
Okay.
So as Madam was saying, initially Madam taught us how to find the inverse of a given function. And then sometimes the function you'd be given, the function they're going to give you, you can find the differential or the derivative of what is thrown into the function. So this formula is used to find the inverse of the derivative of a particular function. So that is why we are saying that it is tantamount to 1 over f prime or f derivative of the inverse of the function. So what Madam is saying is in line. Thank you.
Okay, thank you very much. So, we want to note a few things that f of x is the absolute x minus 2 is not a one-to-one function. Reason being that f of x has y values that are paired with more than 1. So if you have the absolute of a linear function, or yes, what happens is that it will have more than one value. So when you solve it, you realize that because if you find the absolute of a number, it is going to be positive. So if you have negative number and put it there, you are getting positive 3. Let's say negative 1, you are getting positive 3. And positive 1, you are getting, you see, it will cause an issue. Or maybe two different x values will give you the same y value. That function too is not a one-to-one. So we are saying that the absolute of x minus 2 or the absolute of a function is not one-to-one. It passes a vertical line test, but not. So vertical line test is used to find for a function. And the horizontal line test is used to determine whether a function is one-to-one. So let's note, horizontal line test is used to determine whether a function is one-to-one, and the vertical line test is used to determine whether a mapping is a function. Yes. So let us note that. And then we are saying that one-to-one functions, we can check that the function q with that interval defined on that is one-to-one. So they are giving you some restrictions and some things that you should note when it comes to one-to-one functions, about trig functions and then natural logarithmic functions. So I don't know if on this note there are any questions.
Yes, madam, I've raised my hand.
Okay. Please.
I will be glad if you can solve one more example under the derivative of an inverse.
Okay. So we can use our earlier examples that we were doing. So let's go back here. This question. So let's find the derivative of the inverse that we got. What are we going to get? So realize that we had f of x is equal to 2x plus 1 all over x minus 3, and the inverse was 3x plus 1 all over x minus 2. Let's go back to the board. So we want to find, we know this is 2x plus 1 all over x minus 3. Let's find f prime. So we are going to use quotient rule. So we have x minus 3 all squared. So we leave x minus 3 and we differentiate the top, which will give us 2. I'm continuing down, so pardon me. Minus, you leave 2x plus 1 and differentiate what is at the down, you get 1 equal to, so this will multiply. So we have 2x minus 6. This will remain the same, so you will be left with 2x minus 1 all over x minus 3 all squared. So this and this will cancel. We'll be left with negative 7 over x. What am I writing? Negative 7 over x minus 3 all squared. So this is f prime. Now we want to find for f inverse the derivative, and we are saying it's 1 over f prime of f inverse, and we have 1 over f prime is entire of this, but wherever we see x you put this there. I have negative 7 all over f prime minus minus 3 all squared. So we would have 1 all over. We had this one will be a bit lengthy. So f inverse we had 3x plus 1 all over x minus 2 minus 3 all squared. It's a bit complex, so let's solve. So this we will have x minus 2, 3x plus 1, x minus 2. This is long. Okay, let me do it with x minus 2. I don't want to confuse anybody.
Madam,
So what you say?
madam,
You are confusing somebody. Yeah.
I think where we phrase is okay, we can apply our algebraic skills. So let's
Okay.
continue.
So thank you very much. So it's the same. I don't want to confuse anybody. I'm sorry. So it's. I think we have 5 questions. You just have to have questions. So the questions that we solved earlier, you can decide like g of x is equal to be found for that inverse to be what did you get? What did we get for that inverse? X squared minus 4 over 4. So you can find the derivative of g of x and then apply the formula. So the examples that we've done already, and then you'll be okay. So we are done with the first slice, which is about one-to-one function. Any other questions that anyone is having?
Madam, please, how can we get the slice we are using?
Any other questions before we proceed? Any other questions? Okay. So the next thing we'll be looking at is inverse function and differentiation. Inverse function and
Madam,
differentiation. Okay. Please, I'm listening to you.
Please, are we done with unit 1?
Yes.
Okay,
Madam, we are
thank
suggesting that the next time we continue unit 2 because some of us are confused.
I don't get it. Confused as in.
Please, it's not your time. Please, it's not your
Time on
time.
so Madam, come I break there 10 minutes beyond. Na
Okay.
include adwene kakra.
Okay, so we would resume on when it's 120. Is that fine?
It is cool. It is cool.
Madam, you kindly share the slide with us.
I'm not part of your group. Oh. So
Oh,
unless you ask,
the course rep will be adding you soon. Immediately you drop your number.
so maybe when we are done.
Hello, madam.
Mm-hmm.
Please, when do you say a function is injective? Because I didn't. Uh,
Oh, it's the same as one-to-one.
one to one.
An injective function is a one-to-one function.
Okay.
Is there another name for one-to-one?
Okay. Thank you.
You're welcome.
All right, so break time, please.
Hello. Hello. Please, are we there?
Yes, madam.
So our break time is over. So we want to proceed quickly and then move on to the next slide, which is about. So this one I'll move a little bit. Yeah, so we'll be rushing a little bit. So you move with me, okay? But if you don't understand anything, do well to prompt or speak up. Maybe I won't see the notice, so you just speak up and then you move forward. So this slide we'll be looking at and differentiation, and the goal of this um, lesson is to use differentiation techniques for solving problems involving inverse, we've done circular and exponential functions. So let me move a little bit forward. We've done how to use the differentiation technique to solve for inverse. Yeah. So this time we want to apply circular functions. Circular functions are the trigonometric function, sine, cosine, tangent, and exponential functions and natural log, logarithm, log functions, and then link. Yeah. So that is the whole idea. So the introduction, I'll move fast because I've actually explained them. It is the ending part of the slide one. So it says that the inverse of a function y is equal to f of x. It's a function in some fashion reverses or undoes the effect of a function of f. So inverse, we are trying to say we want to find the reverse of f or the opposite. So the inverse of f, we said it is denoted by f inverse. And so we said also that the statements y is equal to f of x and x is equal to f inverse of y are equivalent. And we made mention that their graphs are what? Identical. So their two derivatives, assuming they exist, are reciprocal, as the Leibniz notation suggests. So something new here, we are trying to say, for when you look at the first statement, it says the inverse of a function y is equal to f of x. So if you want to find the derivative of that function, it's going to be dy dx, and its derivative, the second statement, the statement y is equal to f inverse of y, it's going to be dx dy. If you find the reciprocal of both, it should be equal to 1, because dx will cancel dx, dy will also cancel dy. So it is like a chain rule. Yes. So writing explicitly the dependence on y on x and the point at which the differentiation takes place, and the formula that we stated, how to find the derivative of the inverse, they've stated it again. Yes. So the next slide is an example. We want to use the Leibniz notation to check whether when we have the derivatives, you are going to get 1. So we have the function y is equal to x squared. So what will be the inverse? So let's quickly solve for the inverse of y is equal to x squared. What are we getting? Quickly. What's the inverse of y is equal to x squared?
2x.
2x. Are you sure? I'm saying the inverse, so not
We are
derivative.
having x is equals to y squared.
Madam,
Y,
the answer is root of x.
x, x is equal to what?
X is
Square root
equal
of
to
Square root of
x.
y.
square root of y.
Okay. So now we have y is equal to x squared. Let's find dy dx. What are we getting?
2x.
2x. And then let's find the x dy. Because now when you found the inverse, you had x is equal to root y, right? So what will be the x dy?
1/2 root y.
Root y. Okay. Now let's find dy over dx times
Madam,
dx.
how? Why? How did you get a 1 on 2 root y?
Okay. Moving faster, so please be moving with us. So this is what we are trying to do. We have a function, okay. We have the function y is this big. We have the function y is equal to x squared. Okay, and we want to find dy. Let's start this way, dy dx. We are getting 2x. Now I want to find the derivative of this function, so we are going to interchange. No, we want to find it, so we find x is equal to root y. Are you getting it? So meaning that y inverse is equal to, it's not even going to be x, so this is what we have. So we want to reverse it so that when we can find the dx dy. When you do it, it's easy to find your dx dy. This one was in this form, so we're able to find dy dx. We have this. And this one, I want to do it so that x becomes the subject, so that we find dx dy. And this, when you differentiate, you get 1/2 root y. Do you agree? Please, you agree?
Madam, I think that is where we have the confusion.
Why? What's the confusion?
How do we come by 1 on 2 root y?
This is different. This one you can rewrite it as 1/2. When you differentiate it, you get 1/2 y negative 1 on 2. That is all that we were doing. And so this can be rewritten. So dx dy is now the same as 1/2 root y. Is it clear? This I need responses. Is it clear?
Yes, madam.
Yes, madam. This is clear, but the former one could have been more simpler than this.
When
Where
you
we
had
have
it,
2 y, the y dx equals to 2x.
so find dx dy.
No, the y dx is equals to 2x.
We've done that already. We are trying to solve something.
And
Okay.
then when you
So
find the
I
inverse,
think
yes.
with this one we are differentiating with respect to y, not x. That's why we got.
I get the
No,
you are
it's
trying
the
to
same.
say that we
When
can.
you
I
find the
get
y
you. You
dx,
want to
it's
find the
just because of
inverse.
the inverse of the this thing, and then
Just
in
tell it.
place of you put the value of x there. That's all.
Yes, I get you, but I want to start from somewhere. You can just interchange it. But I want to say that you can find the derivative with respect to y, the derivative with respect to x. It's still the same thing. You can use this one and just reciprocate it. So that become dx dy is equals 1/2x. It's also correct. Please, is it okay?
Madam, I had 1/2x, but I'm doing on my car.
So it's still the same. So this side, what happens to this side, this particular side is that we know that y is equal to x squared. Then you come and fix it inside, and then so what happens is now you would have 1 over 2 in brackets with x squared. This is cancel this, and you have 1 over 2x. It's still the same thing, but they want you to see how it came about. That is all. Please, are we fine?
Yes, madam. Madam, fine.
Okay. When you do that, when you multiply both of them, you get 1. Am I correct? When you find the dy over dx times dx over dy, which is 2x times 1 over 2x, you are getting 1, right?
Yeah.
All right. So the next example, let's try and solve for this one too. This is an exponential function. So let's find the derivative of e to the power x, which is dy dx. What are we getting?
E to the power x.
And what will be the inverse, which is dx dy?
1 over y. That's 1 over e to
So,
the power x.
okay, so when you multiply both derivatives, what are we going to get?
Going to be 1.
All right, so is it clear? This is very simple.
Yes, ma'am. Yes, ma'am.
All right. So we've come back to the graph again. I'm just going to state.
Mankasa, dan ebe me awosu. Mankasa, dan ebe me awosu.
So we are coming to look at the one-to-one again. I said that when you have a one-to-one function, you can perform the horizontal line test. If the line cuts only 1 point on the graph at any time or once, you would realize that it is one-to-one. So if you look at this, the horizontal line y1 cuts 1 point, the horizontal line y2 cuts 1 point, the horizontal line y3 cuts 1 point. So this implies that it is a one-to-one function. And if you look at the sketch very well, this is a linear graph. It's a linear function or a linear graph. So that is why it is one-to-one. So there is a note down there says that decrease on its entire domain in general. So this one, it is a decreasing function. Yes, a function that is either increasing or decreasing on its entire domain, such as f of x is equal to negative x. So these are some of the examples of one-to-one functions. So f of x is equal to negative x, f of x is equal to x to the power 3, and g of x equal to root of x are all one-to-one functions. And then the next thing, we want to show that the function of the mapping to n h of n is equal to n plus 1 if n is greater than or equal to 0. So we want to check for. So this one is I think it's a piecewise function. I'm coming. I'll rewrite it for you because I think there's a way it's supposed to be written. Greater than or equal to 0 and then negative 2n n less than 0. So I want to find h of 1 and then h of negative 1 to 2. Okay. So let's go back to the so we have a piecewise function. Plus 1 such that n is greater than or equal to 0, or when it is negative 2n to imply that n is less than 0. So this is what we have. And they're asking us to find h of 1 to be equal to 3 when n is greater than or equal to 0. So because of this particular rule here, you are going to use this one for the first one. Okay, so this implies that when we have h of 1, meaning that whenever you see n, you put 1 there, you have 2 of 1 plus 1. It will give us 3. That's what we are saying in here. Please, is it clear? This is clear.
Madam, please, your line is breaking.
Hello. Hello. Please, can you hear me now?
Yes, please.
So is it clear?
Kindly position yourself. We are struggling to hear.
Hello.
Hello.
Please, can you hear me?
Yes, please.
Okay. So the next one was asking us to find when n is -1. We said when n is less than 0, this one should be 2. So meaning that you are going to use this rule. So -2 of -1, this will give you 2, and this is the answer they are given, and which is correct. So it's actually a piecewise function, which is telling us what to do. So the answers are ready. And the example, second one, it says that which of the following functions are one-to-one? So you are going to tell me which of them are one-to-one. They've even solved it down there. So A, f is such that r maps to r, that is real numbers to real numbers. F of x is equal to x cubed minus 2x squared plus 1. The first one, is it going to be a one-to-one function, or it's not going to be a one-to-one function? If yes, why?
It is not going to be one-to-one function since it's a quadratic equation.
Okay, why? If it is a quadratic
It's not
equation, what
quadratic. It's polynomial function.
polynomial of degree 3. So what happens? What
Yes, madam, we
happens?
can have
It is going to cut two lines. The horizontal is going to cut two lines, so therefore it is not linear.
So it implies that two elements in the domain would map to might be able to map to one element in the codomain. So like 0 and 2, they will have the same image, and because of that, it is not going to be one-on-one, because we said that for one-to-one functions, every element in the domain should map to one and only one. But in this case, two elements in the domain are mapping to one element in the same element in the codomain. Very good. What about the second one? We have Jane is such that 2 to infinity, x cubed minus 2x squared plus 1. This one, it is restricted because this one has a restriction. Our domain starts from 2 to infinity. So what happens to the function? Is it going to be one-to-one? Is it going to be one-to-one?
Yes, because each
Madam,
value
yes.
will give a unique
It's
answer.
1-to-1.
1-to-1.
It's one-to-one. Why? Why is it one-to-one?
Any
Because there is
positive
a
value
restriction.
from
Madam, because the
2 to
element in
infinity.
the
Yeah.
domain will get unique elements in the codomain.
The codomain. Very good. So let's go to the C. Mapping. Let's go to the C. This one too, it is real numbers to real numbers. So our domain is all real numbers. Our codomain is all real numbers, and the function is x to the power 4. That function, is it going to be one-to-one?
No, it's not.
Why?
Because it is an even function.
It's an even function. So what happens if the function is even?
When you substitute negative, let's say -2 and a +2, you have the same answer.
We'll have the same image.
Yes, please.
Okay, so that is fine. Thank you very much for your submissions. So we move on to another
Madam,
example.
please, I have a question.
Okay, proceed.
Go. Yeah, with the first one.
Okay.
So is it a one-to-one or is not a
It
one-to-one?
is not. It is not one to one.
Okay.
Are you okay?
I'm not that all that clear.
The explanation, the
Yeah.
explanation
Okay.
for
It's
that
not
one.
going to be one to one because assuming the function you have x is equal to 0, what will you get for f of 0?
I think it's going to be one.
And when you have f of 2, now put 2 in the function. What are you getting for the answer?
Okay, 8 plus.
Same one. It's
It's
Same
one.
one.
one. So it
Yeah.
implies that the domain 0 and 2 are mapping to 1. And because of that, it's not going to be one to one because one to one, each element in the domain should have a unique element in the codomain. But here is the case 0 and 2 have the same image. Please, are you getting it?
Okay. So if the negative sign had or is positive within the
Which,
this and the function,
which
is
negative?
that one going to be one?
If which negative, please?
The x exponent 3, the minus there.
We don't look at whether it is negative or positive. Oh. There is a way you solve. I think I solved it earlier. F of
Please,
when you
he is saying that when the question is s cube plus 2s
no,
squared
it
plus
doesn't work like
1.
that. It doesn't work like that. You can use other things to determine whether it is not one to one. And this is just a counter examples. For counter examples, we use values. But if you want to check itself, you use a proof. And the proof, I said f of x1 equal to f. If f of x1 is equal to f of x2, then x1 should be equal to x2. So if you do this, and then at the end of the day, you are having unique x1 to be equal to x2, it implies that the function is one to one. This one, they are using counter examples, which is also the same. Please, do you get it? It is not about whether it is the sign is positive or negative. Probably it will work, but it is not always like that. Please, are you okay?
Yeah.
So let's quickly look
Madam,
at something.
madam.
Yes.
But how if you try in order, or how do you just arrive by the 0 and the 2 to do the testing?
It's counter example. You find values that when you put inside, you can get the same image.
My question is, how do you easily get those values?
Abi is try and error you test. There are values that you test with. So some people, because look at the rule of the mapping. It says f is such that r maps to r. So real numbers to real numbers. So your real numbers you can have as many values there from infinity, negative infinity to positive infinity. So you can use um, the proof to check, or maybe just counter it. And when you look at the equation, something that when you see you would. So it is trial and error, but you have to be smart about it. Yes. Is it okay? You're just picking numbers to
Madam,
put
you're
in
very
there.
sick. You're very sick.
You are just picking numbers to put inside, whether you are going to get the same range or not. Is it clear?
Yes, please. Let's move on.
So inverse function, we are saying certain pairs of one-to-one function undo one another. So we are saying that if we have a function and its inverse. Let's say f of x is equal to, so let's check whether let's find the inverse of f of x, which is 8x plus 5. 8x plus 5. What is the inverse of 8x plus 5?
Madam, it's x minus 5 all over 8.
All over 8. That is what we are given here as gene of x. They are saying that assume that you have the f of x, and now they are asking you to find f of 10. What will it be? What is f of 10?
Wherever
Madam,
you see
please.
X, you just put it in there and simplify.
Yes. So what will it be? What is the answer?
85.
85. Now let's find gene of that 85. What are we getting?
10.
Madam, the same thing.
The same thing, 85.
No,
No, you
10.
get 10. No, you get the same answer
Okay.
as
So you realize that when you have the function, you find the answer, and you put the answer in the inverse, you would produce the initial. So inverse. Let's try for f of 10. 14. Find f of 14. F of 14.
$117.
18.
117. So let's find J of 117.
Please come again.
It's 14.
you get 14.
14.
14. So please, are you seeing a pattern here? If you have the value for x and then you solve for f of that x, you get an answer. And that answer, you put it in J of the f of what the value for x for the initial. So the inverse, you see it is applying. Please, do we get it?
Yes, please.
Okay. I think the next question, we solved it. We've done it in the first slide. Do we agree? But this one, we did it stepwise. So we realized that when you solve for, we have f of x is x cubed plus 1. They are asking us to find f inverse of 9 and then f inverse of 28. So first of all, you have to find the inverse of the function f of x. And that is the procedure they went to. They made f of x to be equal to y, and then they interchange the positions of x and y. And then you make y the subject, and you are going to get the cubic root of x minus 1. And now wherever you see, we want to find f inverse of 9. Wherever you see x, you put 9 there, and you are going to get 2. And the next one, wherever you see x, you put 28 there, and that one, so you are going to get 3. Please, are we fine?
Yes, please.
All right. So the next example, so this one is more of examples. So the next example we want to solve, let's try and find the inverse of x. You are doing it for me. The inverse of x. Me if you want to. So the function I'm writing, listen, f of x is equal to root x plus 5. What is the inverse of root x plus 5?
X squared minus 5.
So f inverse is equal to
X square minus 5.
minus
x.
5.
minus
All
5.
right, that is very good. Now let's find the domain of f inverse of x. the domain of f inverse of x? What is the domain? We did it earlier, so I'm waiting for you. What is the domain? We also have a square root x, so let's see those who really understood it from the beginning. What is the domain?
The domain of the F inverse
Yes.
is all real numbers.
Are you sure?
The domain is x squared minus 5. There is no square root.
All right, very good. So
The
the domain is all real numbers. So any real number, real number you put there, it will be defined. So what about
is
the range? What about the range of the f inverse of x? The range of f inverse of x. 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 What is the range?
Now,
Okay.
is it all real numbers? Then y should be greater than 5.
No, it's not going to be all real numbers. The range will, the domain is all real numbers. But
Y is greater than 5. Y should be greater than 5.
what should be greater than 5?
Y,
Y should be greater than
5. 5.
greater than or equal to or
Oh, okay. Greater than or equal to 5. To 5. Yeah.
so looking at here, we found for the f inverse to be x squared minus 5. You had it correct. That's good. So the next thing too should be that remember okay, the next thing is that the domain is -5 to infinity, right? The domain is -5 to, so the range of the domain is this. The first one is the domain of f, -5 to infinity, and the range is all real numbers 0 to infinity. That is the same for the other side. So for the domain, we said it is all real numbers, that it should be from 0 to infinity. And then the range will be -5 to infinity. This is it clear? So we have, you remember at the end of the first slide, we made some restrictions. So for trig functions, they are actually circular functions. And if they are periodic functions because as one is, let me sketch something quickly. Let me do something quickly. When we say it's periodic, we are trying to say that, let's say we have the graph. As one function is going this way, I think this will be, is it the cosine or the sine graph? One will be going this way. Okay. So it makes it the trig functions are periodic. So what happens is that if there are no restrictions to then what happens is that it will not be a one-to-one function. To not be one-to-one. So here is it. Trigonometric functions are periodic, therefore each range value is within the domain, no break in between. So since this trigonometric function has no restriction, there is no inverse. So if a function is not one-to-one, we are saying that it won't have an inverse because this one does not have any restrictions to it. So it won't have an inverse because certain things will not. To have inverse function for trigonometric, we restrict the domain. Like this example. I don't know if it is here. This one. You remember that the A part, we didn't restrict the domain. So the domain was all real numbers. So the A part, you realize that when you put that function inside, so A and B are the same functions. Note it. It's x cubed minus 2x squared plus 1. They are both the same. But the difference was that for the B part, the domain was restricted from 2 to infinity. That is why it made it a one-to-one function. But when it is not restricted to the domain, it will not become a one-to-one function. That is the same ideology that we want to apply to trig functions. If there are no restrictions to their domain, they are not one-to-one. But if there is a restriction to its domain, it becomes one-to-one. So here, what happens is that this trigonometric function has a restriction to its domain because the restriction now becomes the interval, which is negative pi on 2 and pi on 2. So it is strictly bounded. When it is strictly bounded, when you sketch the graph, this is what you are going to get. And when that happens, it is the blue line. The sketch is actually the blue line, not the dotted ones. So that's just that blue line. So what happens is that when you draw the horizontal line test, will it cut only one point on the graph? Yes or no?
Yes.
But yes.
Yes. Yes.
Because of that restriction, when you draw the horizontal line test, it will cut only one point on the graph, and because of that, it becomes what? One-to-one. So if there are no restriction to the trig functions, they are not one-to-one because they are periodic functions. What happens is that the sine and the cosine will be intertwining with each other. And when that happens, when you draw the horizontal line test, let me use this one. When you draw the horizontal lines, you see it is cutting more than one. So when that happens, because it is having no restrictions, it makes it not a one-to-one function. But when the restrictions are applied, it makes it a one-to-one function. Please, are we okay with the explanation?
Yes.
All right. So the next thing we want to look at inverse. So we are done with the inverse, and then we want to look at circular function. We started circular function. This is where we started it from. This is where, so trig functions, I stated that they are circular functions because they've been intertwining, and we are saying that they are also periodic functions. So now, knowing this, we want to I skipped something. We want to find inverse of a sine function. If you have a sine function, how do you find the inverse or inverse sine function? So sine inverse, or sometimes you can hear arc sine. So arc sine is the inverse of the restricted sine function. Y is equal to sine x on the interval negative pi on 2 and pi on 2. So let me try and then, so there's that interval, it is in the radians. So that is the x part, the interval there that we are seeing, pi on 2, negative pi on 2 and pi on 2. They are for the x part. But when you want it for the they are for the y part, sorry. When you want it for the x part, it is going to be negative 1 and 1. So the sign lies between -1 and 1 on the x-axis, pi or 2. So I want to show you something like how we did it and other functions. So you have y is equal to please I'm coming. So we have x. Okay. Now I want to find the inverse. You find f inverse of both sides. You find inverse of both sides. So that is equal to sine x. Okay. Now I want to find the inverse. So if you find inverse of both sides, you are going to get f inverse of sine x, which will give you x is equal to f inverse of this. Please, are we okay? So it is like the normal idea that we are borrowing. And you know f inverse of sine x is, can we write it? No, I'm sorry. So the equation y is equal to sine inverse of x, or y is equal to arc sine, or which also means sine y is equal to x, where you have that. So what you do is that you don't find the inverse, we find sine of both sides. That is the problem. I was doing something wrong. Please, I'm sorry. So this is what you have. I got confused a little bit. So you have y is equal to sine x. You want to find sine of both sides. Sine inverse of both sides, rather. So you have sine inverse of sine x of sine. Remember this thing from f of f inverse of x should give you what? X. Please, we remember this. Hello, are we there?
Are with you.
We are with you, but it seems we are confused.
Okay, so let me come again. I'm sorry. We are talking about the inverse of sine. Okay, so this is what we
But,
have.
but what you have written is there is no inverse. So you have written y is equal to sine x.
I know, take your time. So we have, I want to establish something. So you have y is equal to sine x. Okay, we want to find the inverse. So when you find inverse, what you do is that you find the sine inverse of both sides. You find sine inverse of both sides. So this will become sine inverse of y is equal to sine inverse of both sides. This one will give us this of x, which is this, right? Am I right?
Yes, madam.
And remember
Madam,
that, okay. Remember that if you have a function and its inverse, it will give you only the x y. So sine inverse of y will be equal to x. So now we have this and this. And this is the inverse of this. Are we okay? I just want you to see how it came about. So you have a function y is equal to sine x. You want to find the inverse of a sine. So what you do is that you find sine inverse of both sides, and it will change to this form. That is all that I want to show you. Are we okay?
That's what I
Emu da hɔ paa.
So now I have a question.
Okay, please proceed.
So for the first one, are you not going to exchange the variables?
Please, I can't hear you. Speak louder for me.
I said, are you not going to exchange the variable for the page universe?
No, we are not solving a question like a question. So it's this one we are just stating how it should look like. That if you have like how we were doing for the initial, when you have y is equal to f of x, and then when you find f inverse of both sides, it now becomes x is equal to f of y. That is all that we want to just do. But it also goes through the same procedure. When you want to find the inverse too, it also goes through the same procedure where you interchange x and y, you make the same, it doesn't change. I just want you to understand it when it is also sign function. That is all. And remember that for this one, it is restricted because it is bounded in an interval. Please, are we okay? So if you look at the sketch for the sine graph, so what happens is that the sine graph and its inverse, that is the sine function and its inverse, they are also identical because a function and its inverse they have identical graphs. We stated it in the first slide, the theorems. So the same thing, this is how the sine graph looks like. And remember, you see that it is bounded. X pi on 2 and pi on 2, 1 and -1. You see it is bounded. So the same thing, because it is bounded, when you draw the horizontal line, it cuts only one point on the graph. And this is a one-to-one function. Are we clear? So the same ideology when you want to find the inverse, as you were saying, you can interchange the x and y positions and you find the inverse. It's still going to work. Still the same thing. So when you do it, you are still going to find. So look down beneath it, the last statement there, it says that sine of sine inverse of x should give you what? X. Please, are we seeing it? Are we seeing it? Yes or no? Sine
Yes.
and
Yes.
it is like the previous one. We said f of f inverse of x should give us what? X. It is the same application to here. So nothing is changing. All that is changing is that this time we are looking at what? Circular functions. That is all. So let's look at something here. Remember that whenever we are saying something here that sine and sine inverse of x should give you x, where so there is a caution, there is a clause. The x value should lie between -1 and 1, where -1 and 1 are not inclusive, because it's not less than or equal to, but it should be less than or equal to. Ideally, it should be less than or equal to, but they didn't do it less than or equal to. So x value should be between -1 and 1. When that happens, then we can say that the sine of sine inverse of x is equal to 1. So let's look at something here. The first example says sine of sine inverse of 0.5. So is 0.5 lying between -1 and 1? Is 0.5? Yes. So because of that, we can say that sine of sine inverse of 0.5 is equal to 0.5. But look at the second example. If you have a calculator, punch sine of sine inverse of 1.5 and let's see what we are getting. If you get an answer, let me know. Sine of sine inverse of 1.5. Are we getting an answer for that?
Oh.
No. So you realize that because the x value is not lying between -1 and 1, it does not exist. But let's punch sine of sine inverse of 0.5. What are we getting?
It
Half,
says
1 over 2.
0.5.
1
1
over
over
2.
2.
Very good. Now, the next, so you note the first note is that sine of sine inverse of x should be equal to x when the interval is -1, when x lies between -1 and 1. The second one is the sine inverse of sine x should be equal to x when x is lying between -pi/2 and pi/2. Are we okay? The first part is this when the sine is coming first and the inverse is inside. We are saying that for that one, x should lie between -1 and 1. But when the inverse is outside and the sine x is inside, we are saying that the interval should lie between -pi/2 and pi/2. So now let's take our calculators and punch sine inverse of sine -1.5. What are we getting?
-1.5.
-1.5, because this x value -1.5 lies between -pi/2 and pi/2. What is the equivalence of pi/2 in degrees? What is the equivalence of pi/2 in degrees?
90.
90.
90 degrees.
90 degrees. So they are saying that for this second rule, it should lie between -90 and then 90. So we realize that -1.5 lies between this interval, right? 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 Yes or no?
Yes.
Yes.
So
Yes.
because of that, it exists. So let's try and then I want to find a counter to this. Let's try and find sine inverse of sine 91, or maybe sine of 2 pi. Use 2 pi instead, or pi. So someone should use pi, someone should use 2 pi. What are we getting?
2 pi is 0.
2 pi is there. What about pi?
It's also 0.
You see, so you realize that on that point, all of them will give you 0. But when they are lying on the, they are circular. So it changes it. But all that you have to notice that for the second part, when the sine inverse is
Eh,
outside, sine x
Madam, we
is
didn't get to
inside.
explanation. Your line went off. Immediately you said, and then off.
I'm saying that when the sine inverse is out and sine x is inside, the second rule that you are stating here, this side, know that your x interval should be negative.
Hello, madam. Please, we can't hear you.
Hello,
Madam,
can you hear me now?
we can't hear you, your voice. So, yeah.
Hello.
Hello, madam, we can't hear you.
Hello.
Hi.
Hi.
Please, can you hear me now?
We can hear you. Yeah, we can hear you now.
Okay. I'm sorry for the disturbance. So, um, I'm saying that let's note this. Let's make it simple for ourselves. For the first rule, when sine inverse is inside and the sine is outside, it should give you x if your interval is x lies between -1 and 1. The second one, if sine x is inside and sine inverse is outside, it should give you x when your x is lying between -pi/2 and pi/2. Are we okay?
Yes.
All right. So now we'll be looking at natural log, which we also call ln, as the inverse of exponential function. So what we are trying to say is that the natural log is the inverse of the exponential function e to the power x. So if you have a function f of x to be equal to e to the power x, I want us to do it manually before we come to the slides. I want us to solve it together so that we see how the natural log is the inverse of the exponential function e to the power x. So we have f of x is equal to e to the power x. And remember that when we want to find the inverse, we make this one y and then we make this e to the power x. Now we want to interchange the positions of x and y. So wherever you see x, y, we put x there. Wherever we see x, we put y there. Now we want to make y the subject. So what do we do? In this case, what you have to do is that you find the ln of both sides. You find ln of both sides. And then on this side, you apply indices. Indices will state that if you have the ln of an exponential, you bring the exponents down and you are left with the ln e. Ln e is 1, so y will become ln x because ln e will give us 1. So meaning that the inverse of x is equal to ln x. So that is why we are stating that the inverse of an exponential function e to the power x is ln x. Are we okay?
Yes.
Yes, madam.
So that is the entire explanation for this particular side of the slide. That is what.
Please share the board again. I want to show something.
Oh, okay. Sorry. I'm sorry. I'm coming. So this is it.
Thank you, please.
You're welcome. So now we are coming to just explain what I just did. So we are saying that for x greater than 0, and please let's note something. For ln functions, let's take our calculators and do this quick inputs for me. Find ln 1. What is ln 1?
0.
Find ln 0.
Error.
Error. Find ln -1.
Error.
Find ln -20.
Error.
Error.
Oh,
Error.
Find ln 2. What is ln 2?
0.693.
Very good. So all that I'm trying to tell you is that ln functions should be greater than 0 because the ln of 0 is error. So when it comes to ln functions, it should always be greater than, the value for x should be greater than 0. Please, are we okay? Because if it is less than or equal to 0, it will give you an error. Please, are we okay?
Yes.
Okay. Now let's look at something for the e to the power x. Find e to the power 0.
One.
Find e to the power 1.
It's 2.718.
2.718.
Okay. Find e to the power -1.
Zero.
Ajawusu.
Please, what are you getting?
0.3678.
0.3678.
Very good. So this is what I want to show you. When you take the natural log, that is the ln x, we are saying that for ln x, the x should be greater than 0. Are we okay?
Okay.
X should always be greater than 0, because if you have less than or equal to 0, it is going to give you error. It does not exist. The value does not exist. Now, it implies that when you find the domain of ln x, you are going to get x is greater than 0. Do we agree?
Yes,
Do
please.
we agree? The domain of ln x will be x is greater than 0. So, can someone tell me the range of ln x? What will be the range of ln x? What will be the y values which will make the function defined? We know that the x value, which is the domain, which will make the function defined, is when x is greater than 0. What will be the y values? That is the range which will make ln x defined.
So, madam, it will be 1 up to infinity.
1 up to infinity. Isn't it going to be all real numbers? Because we said that, we established earlier on that if you have a function and its inverse, so the domain of ln x, listen carefully, the domain of ln x, is it the same as the range of e to the power x? Because one is the inverse of the other. So the domain of ln x is equal to the range of e to the power x. It's a question to the class.
Yeah, it's equal.
So now,
Yes.
so now the same thing, the domain of, listen carefully, the domain of e to the power x, is it the same as the range of ln x?
Yes, madam.
So what is the domain for e to the power x? Because I made you punch e to the power 0, you said you had 1. I made you punch e to the power 1, you had a value. I made you punch e to the power -1, you had a value. So what is the range? What is the domain of e to the power x?
I think it's all real numbers.
All real numbers. Very good. So meaning that the domain of ln x is x greater than what? 0. But the range is all real numbers. Have you seen it? Please, have you seen what I'm trying to say?
Yes, madam.
Yes. So that is all that I want to establish with you. The domain, the range, so that you know how it works. Now let's look at something. The same thing that we did for the sign, you're coming to do for natural log. When you have f, the function and its inverse, we stated that it should give you x. So if you have, let me go back to the board so that all I come to explain so it becomes easier. If you have if you have, we are saying that f of f inverse of x should give us what? X. And the function we are saying it is going to be, what is it? It's e to the power. So e to the power ln x. The function and its inverse should give you x. This one, we can rewrite it as applying indices. You can write it as ln x times e, and then x ln e. And this is, we said ln e is 1, and which is x. That is what we had here. Or the other way round, we said that you can have the inverse first, and the function is inside the inverse. It should also give us x. So we did for this one. We want to do for when it is ln x. So this time, wherever you see x, is going to be e to the power x. This, when you write it, you can write it as this. Indices will teach us that you bring x down to be left with ln e, and we are saying ln e is the same as 1, so you get x. So all that I'm trying to say is that if you have a function, the natural log and its inverse, it should give you x, no matter how it looks like. This one, they don't have a condition like the sign, because it's a periodic function. It had a strict interval. This one doesn't look like that. This one is like the normal one. The function and its inverse should give you x. So a quick one, what will be x? What are we getting? Ln e to the power 3x. What is the answer? I want to see something. What will be ln 3? What will be ln e to the power 3x?
Madam, please, your line is breaking, so come again.
I'm saying that what would be ln e to the power 3x? Very good. What about
3x.
e
3x.
ln 3x? E to the power ln 3x.
3x.
ln 3x.
E to the power ln 3x. What are we getting? What are we getting? E to the power ln 3x. What are we getting?
ln 3x.
It's not
3x.
going to be ln 3x. So it's just going to be 3x. Yes. You apply
3x.
indices. So this one, it was x. When they change it to 2x root 2, and it is the function its inverse, you just write there what is left. That is all that I'm trying to say. Alternatively, we can use the formula, yes, to find it. That one too is still going to be the same. They want to show you the proof. That is, we know that f of x is equal to e to the power x, and g of x is equal to ln x. So when you, excuse me, sorry, when you find the derivative of ln x, when you find the derivative, is it derivative? When you find the derivative of e to the power x, we're going to get e to the power x. You put it back inside, you still get the same thing. So that is the rule there. This thing is very short. So let's try this example. F of x is equal to 5 to the power root x. Please solve and find the derivative, the inverse of, I don't want you to see. So I'm reading the question. F of x is equal to 5 to the power root x. 5 to the power root x. Find the inverse. What will be the inverse? F of
Your question
x is
again.
equal to 5 to the power root x. F of x is equal to 5 to the power root x. Please, what are we getting? What are we getting? What are we? What are we getting? What are we getting? What are we getting? What are we getting? Mm-hmm. You just make y equal to 5 to the power root x. Interchange x and y position. So you are going to get x is equal to 5 root y. We want to make y the subject. So because of that, we find lane of both sides. So you have lane x is equal to lane 5 to the power y. Indices, you bring the roots y down. So you are going to get lane x is equal to root y lane 5. You divide both sides by lane 5. So you get root y is equal to lane x over lane 5. And y, you square both sides. Y will become lane x over lane 5 all squared. So that will be our inverse for that function. So now this is what we want to actually do. We want to find the derivative of f of x. We want to learn how to differentiate an exponential function. So I'll go through the process with you and you see how it. So we are solving it together. So you help me as well. So we have f of x is equal to 5 root x. So we want to differentiate. So to make everything easier, we make f of x equal to y. So y is equal to 5 root x. So when you have this, what you will do is that this one you're finding derivative, not inverse. So what you will do is that you find lane of both sides. You find lane of both sides. So after finding lane of both sides, the right hand side, you apply indices to it. And you are going to get root x lane 5. So now we have to differentiate both sides. So lane y, it is an implicit function. So you are going to differentiate lane y. When you differentiate lane y, you get 1 over y. And because it is an implicit function, we want to differentiate with respect to x. But this one, because it is implicit, you would have to bring y prime. And then equal to, the right hand side is, you can use product rule. You integrate with x and leave with 5, and then later you come and differentiate with 5 leaving with x. So we are going to leave with 5, and when we differentiate with x, we are going to get 1 over 2 root x. And you differentiate with x, you are going to get 1 over 2 root x. And now we want to, and then because it's product, now we are going to leave with x and differentiate ln 5. And ln 5 is a constant. When you differentiate a constant, is 0. So now we have, so now what you will do is that you multiply both sides by y, so that you would have your y prime to be equal to y ln 5 times 1 over 2 root x. So this, we know earlier that we stated earlier that y is equal to what? 5 root x ln 5 all over 2 root x. I think there's a problem here. Is that correct? Without the
Yes,
mistake.
madam.
Okay. So this is our differential. So we have y prime is equal to root x ln 5 all over 2 root x. So when you have an exponential function, what you do is that your f of x, you change it to be y. When you change it to y, you find the length of both sides and you bring the exponential down because of indices. After that, you differentiate both sides. The y side, because it is going to use implicit differentiation, after differentiation, you bring y prime equal to the right hand side you differentiate. And then you cross multiply the y and you'll be left with y prime equal to y times something. And earlier you stated that your y is equal to something and you insert it back in and then you find your differentiation. So here you realize that it is the same thing. So we said that let y be equal to 5 to the power root x. They took length of both sides. And when they took length of both sides, this is what they had. And the right hand side, they rewrote it as with x length 5. And they took derivative with respect to x for both sides. And when they differentiated, at the end of the day, dy dx, which is the same as y prime, is equal to ln 5 over 2 root 5 times 5 root 5 to the power root 5 root x, sorry. So that is how you do your differentiation. So this is a keynote. If you have an exponential function, let's say f of x is equal to a to the power x, when you find the derivative, you should get something like the function itself ln the a. So that is all that we had here. Our y prime, we had the function itself, which is 5 to the power root x, and our ln a was ln 5 all over something. So that is how it's supposed to be. Let's look at natural log as inverse of, oh no, we are continuing. So determination of log a to the power x. So we are saying that you can write log a to the power x as ln x over ln a. It's the same as ln x over ln a. And when you are being asked to find the derivative of log of ax, you can find derivative of both sides. You can find the derivative of ln x over ln a. So ln x will give you, so you this side, you apply ln x over ln a, you apply quotient rule. Yes, you can apply quotient rule. And when you apply the quotient rule, at the end of the day, you are going to get 1 over x ln a. Yes, that is the same thing. So let's note that. Or you can solve it another way. Let me help you solve it another way. There's another way you can solve it. I pray it is correct. Um, so let's say they are saying f of x is equal to log a, right? So we can let this y is equal to this logarithm as a ish. A y equal to x. We are seeing it. the ln x over ln a. So after that, you find ln of both sides. You find ln of both sides. So this one indices you have y ln a over ln x. And then you find your y now becomes ln x over ln a. Before you can differentiate the log a. So when you get it like this, now you come and differentiate it. And then you have x 1 over x ln a. Please, is it clear? Please, is it clear?
Since the brain is tired.
Oh my god. Let's
Madam, please go to the board for me.
okay.
Last slide on the board.
This one.
Okay. Madam, thank you.
You're welcome. Please, you shouldn't be tired. We'll finish right now. So this is what we have here. So let's try and solve this. You are doing it for me. I don't want you to see the question. So let's write the question. F of x is equal to 4 to the power x. You write the question 4 to the power x minus 5 log 9x. 5 log 9x. So for this particular one, we've learned how to solve when you have something like the first part, which is 4 to the power x. And we've learned how to solve for the log side, which is we have log of something. So in this particular question, what you do is that you will separate the thing into two forms. You find the inverse when you find the inverse of the first side, and then you find the inverse for the second after that you put them together. Otherwise, if you do it together, you will get confused. So you find the log for you find the derivative for both individually, separately. And you are done. And then you put them together. Yes, when you're done, then you put them together nicely and neatly. So when you separate it, when you differentiate, so we want to do for the 4x. So we are saying that let y be equal to 4 to the power x. When you find ln of both sides, you get ln y. When you apply indices, it will become x ln 4. And then implicit differentiation to the left side, you have 1 over y times y prime is equal to x 4. You apply product 2. So you have ln 4. And then you move the y, you cross multiply the y, you would be left with dy dx or y prime, which is equal to y ln 4. So y ln 4, we know that y, we stated earlier that y is equal to 4x. So now our y prime is equal to 4x ln 4. So after solving it, now you come and do it for the second part, which is 5 log 9x. 5 log 9x. And this 5 log 9x, it can be written as 5 multiplying ln x all over. It should be ln 9, not log 9. It should be 5 ln x all over ln 9, not log 9. So you correct it. So the 5 will go somewhere. The 5 is a constant. You apply, and ln 9 is a constant. So you differentiate the ln x and differentiate ln x, you get 1 over x. So at the end of the day, you are going to get 5 over x ln 9. So now we know for the derivative of 4 to the power x and 5 log 9x, you put them together and then our derivative becomes 4x ln 4 minus 5 over x ln 9. Please, is it clear?
Please, meaning the base is a constant, right?
Yes, the base is a constant.
Okay.
Please, are we okay? Are we okay? Please.
Yes, madam.
All right. So here we'll be looking at some rules and properties. You should take note of them. When it comes to lane, when you have lane x times y, you can separate the indices lane x plus lane y. And then you have the quotient rule. When it's lane x over y, when it is separated, it will be lane x minus lane y. And when it is lane x to the power y, as we've been doing earlier, it's the y will drop down. So you have y ln x. And ln derivative, you are saying that if you have f of x is equal to ln x, there's no I there. So sorry about that. When you have f of x is equal to ln x, when you differentiate ln x, it's going to be 1 over x. And integral, when you find the integral of ln x with ln x dx, you are going to get x plus c. It's supposed to be x plus c. I don't know where that one is coming from. And then when you have ln of positive number, ln x is undefined when x is less than or equal to 0. We've established that already, that for ln, the domain should be greater than 0. And the ln of 0 does not exist. And when you find the limit of ln x as x approaches 0, it is infinity. And when you find the limit of ln, is it ln x or 0? Ln x as x approaches 1, it is going to be 0. And then when you find the derivative of e to the power x, it is still going to be e to the power x. So these are the rules and properties of the natural log and the exponential function. Any question? Meaning there's no question, so let's move on. What is the derivative of the inverse function ln x? So what is the derivative of ln x? We stated that when you find ln x, so we want to find the y dx of ln x.
1 over x.
So 1 over x, that is very easy. So they went through a very long process to get it, but this is how you differentiate it. 1 over the x inside times the derivative of x will give you the function. And then, therefore, if f of x is equal to ln x, then f prime of x is equal to 1 over x. We agree on that. So in general, for a complicated function, so when the function f of x is equal to ln g of x, this is how you differentiate it. It is f prime of x is equal to 1 over the g of x times the derivative of g of x. So when it is 1 over 2x, when you have f of x is equal to ln 2x, what they are trying to say is that when you want to differentiate ln 2x, it is going to be 1 over 2x times the derivative of 2x, which is 2. So for that derivative, it is also going to be 1 over x. So let's note that. And then an example. I believe we've solved this. F of x is equal to ln a of x. Yes, we've done that. And so they are giving you the general form. They are saying that when it is log a of g of x, the general form when you are finding the differential will be 1 over gene of x ln A times gene inverse gene prime of x. Sorry. So you should keep this basic formula in your mind. But remember to apply product with gene rule where needed. Yes. So we have an example of the general basic formulas that we were talking about. So when we differentiate, when we have y is equal to ln x squared plus x, we want to differentiate that. So it is going to be 1 over x squared plus x times the derivative of the x squared plus x. When you differentiate x squared plus x, we are going to get 2x plus 1. So when you differentiate ln x squared plus x, you are going to get 2x plus 1 all over x squared plus x. The next one we want to look at is the log part. So we have y is equal to the cubic root of log x base 7. So this one you rewrite it as log x base all to the power 1 over 3. And we are saying that when you are going to differentiate this, 1 over 3 comes down, you maintain the log function, the exponent will reduce by 1, so to be negative 2 over 3 times the differential of what is inside, which will give you 1 over x ln 7. So at the end of the day, when you differentiate the cubic roots of log x base 7, you are getting 1 all over 3 log s base 7 to the power 2 minus 2 over 3 x ln 7. So it is the same formula, just that this is the general formulas that they are giving you examples of that you should keep note of. So we want to find the derivative of 3 to the power x. 3 to the power x, and we said that let y be equal to 3 to the power x. Then when y is equal to 3 power x, we find both sides. So when you find both sides, you have ln y is equal to ln 3. And when you apply indices, one of the rules, the exponent will come down. So it will be x ln 3. You differentiate both sides. The left hand side will give you 1 over y prime or dy. The other side will give you ln 3 when you apply the product rule. So you cross multiply so that you will be left with dy dx to be y ln 3. And we stated earlier that y is equal to 3 to the power x. So you put it in and the initial question was the answer is supposed to be ln 3. The bottom is supposed to be not ln x. So the dy dx is equal to 3 over x ln 3. That's correct.
Lane 3, yeah.
So it's not ln x, it's ln 3. Yes. So we have another one here as well. This time we are asking to use the inverse function to find the derivative of gene of x 2 to the power x plus 3. So they are asking you to use the inverse function to find this. So what you do is you also go through the same process. Y is equal to 2 to the power x plus 3. You take ln of both sides. Indices for the right side, the x plus 3 will come down. And then you divide both sides by ln 2. So when you divide both sides by ln 2, you make x the subject. They're actually finding for the inverse. So you are using inverse function. You make x the subject. When you are done, you interchange the positions of x and y. And then you will have your inverse to be log s base 2 minus 3. After that, you now find the derivative of that inverse that you found, and that is going to give us 2 to the power x plus 3 then 2. So they are just going through a long process here. So you can do it straight away or use the formula, but the question asks for the inverse formula, and that is the inverse formula. That is the last thing beneath. That is the f inverse prime is equal to 1 over f prime f inverse of x. So this is an example for you to see how it is. The next thing is so these are just examples. So we are being asked to find the derivative of each of the following. The first part is f of x is equal to, so this is a circular function, one of the trig identities. So sine squared x, so we can rewrite sine squared as sine x all squared. Sine x all squared. It's sine x all squared. So we want to differentiate this directly. So when you are differentiating, 2 comes down, you leave the function sine x, and the power will reduce by 1. And then you come and differentiate what is inside, which is the sine x. So it will give you cos x. So the differential of sine squared x is 2 sine x cos x. And then the next one is g of x is equal to cosec x plus cot x minus cos x. Cosec x is the same as writing 1 over sine x. Yes, am I correct? Yes. So when you differentiate cosec, what am I saying? When you differentiate cosec, you are going to be getting sine x minus cosec x cot x. So the final answer will be that. So that one too, it's a trig identity. That we know that negative cos x, when you differentiate negative cos x, you get sine x. So that is the same thing. You apply the trig identities that you learned to differentiate these ones. The same thing for the next example, h of x, root of 2 sec x all over 3. Can we write it as root of 2 over 3? The constant is out. And you will deal with the sec x. And we know that when you differentiate sec x, it is sec x tan x. So that is how it's supposed to be. So these are some formulas that you can keep how to differentiate. So here we're seeing some cosec x, cot x, how you differentiate them. They are identities, so they've been stated here how to differentiate. When you have x to the power n, it would be n to the power x, n to the power 1, n minus 1, sorry. When you have a constant, when you differentiate a constant, it is 0. When you differentiate sine x, you get cos x. When you differentiate cos x, you get negative sine x. When you differentiate tan x, you get sec squared x. When you differentiate cosec x, you have negative cosec x cot x. When you differentiate cot x, you have negative cot squared x. When you differentiate sec x, you have sec x tan x. So all these are some identities that you should keep or you should always remember. These are we okay?
Yes, please.
We are all tired.
Yeah.
So
Yes, it
Yes,
is
so
simple.
madam, let's go Saturday.
I want to end
And
somewhere, so don't worry. I want us to end somewhere so that next time if Madam is continuing, it will be easier. So let's look at when it's okay, it's 3. So let me end with this one. I know we are all tired. Let me end with this one. When you want to, so this one too, we've even talked about it. They are all the formulas, part of the formulas that we should keep. and I'm into side 30. Let me reach here, side 30. And this one too, it is what we stated earlier on. If you want to find the derivative of the inverse, you remember this formula, right? Do you remember the formula? Do you remember the formula?
Yes, madam.
All right, so that is the same thing. If you want to find the derivative of an inverse, this is the formula that you can use. And then let me see. So these are some examples that we can do. We've tackled some of these things already. How to find the derivative of an inverse. I believe we've done it. This one we did it. This we did it as well.
Hello, madam.
Yes.
Please, can you go back some small? I'm confused about something.
What are you
The
confused
formulas you
about?
get, the formulas you gave.
This one.
The first one, and then the last one. What's the difference? Look at it. The last but one.
The first one is still the same as the last one. What they did for the last one is that they did some how should I say? They just did some simplification. Remember that we said that let y be equal to f of x. So they switched the x and y positions, and then when they did that, they found for f inverse of x to be that. They just simplified it.
Okay, so it means the last one, the y is the inverse.
The y is the inverse. Very good.
Okay, okay. Thank
So
you.
it's just the same thing. So this question, we solved it in the first slide. It's the same question here. So this one, instead of going through the formula, using the formula, you can do it straight away with no stress. When you find the derivative, you quickly do the differentiation directly. You don't have to go and put it in formulas and all that. So it will still also yield the same result. And then we have this. So when we have y is equal to x squared plus 2x plus 1, we want to differentiate, we are going to get what? 2x plus 2. So you can decide to do it directly, or you can use the formula to do it. Either way should give you the same results. Yes, either way should give you the same results. So you
So,
see the
madam,
formula part. The
in the
formula part.
exams, what do you do?
Come again.
In examination condition, which method
Okay.
are we supposed to use?
So if in exams there is no um they didn't give you, they didn't tell you to maybe use the formula, you can use any of them.
Option.
Any of them is okay. If exam they don't ask you to use the formula, you can use this one. What matters is at the end
Okay.
of the day you should get the same thing. But if the question asks you specifically to use the formula, you have to go through the formula, the procedure for the formula. Please, are we okay?
So, so finding the inverse before finding the derivative, and finding the
Yes.
derivative first before finding the inverse. Are you going to get the same answer?
Please come again.
That finding the derivative first before finding the inverse, and
The derivative
finding
of
the
what?
inverse, the function,
Finding the
like
derivative, okay, and then finding the, it's still going to be the same, just that make sure that you are doing it well so that you don't mix it up. That is all.
Madam, I don't think so, because we are saying that we are finding the inverse of the derivative. So anytime you have to find the inverse first, after having the inverse, and then you find the derivative of the inverse, and it becomes simple.
Yes.
Why do you then find the
He's
derivative before you come and
asking,
find the inverse?
he's asking for I believe he's asking for the derivative of the question, like the function itself, or
No,
Am
madam.
I right? Okay,
No,
what are you
madam.
asking?
When they ask you to find the derivative of an inverse function,
Derivative of an inverse function. Okay.
yes, I think
You
with
have
a
to find the inverse first. The inverse of that function before you find the derivative.
oh, okay.
Yes, you have to find, because if you are not able to find the inverse, how will you find the derivative of the inverse? So you have to find the inverse and then you find the derivative. Are we okay? But if you are using the formula, it will also require you to find the derivative of the function you were given to, so that you do a substitution and then you solve it. So if your question, the question you are given, let's say the formula, you can go by the direct procedure for differentiation. So the direct procedure, let's say you are being asked this question, you are being asked to find the inverse of the derivative. The derivative of the inverse, sorry. What you do is that you find the inverse, the procedure that we go exchange the x or y values to make y less subject and all that. And then you come and find the derivative straight away. But if you are being asked, is it clear? So this is the formula method. You see the formula is lengthy. The directly move forward. So the formula actually requires, if you're doing it directly, you just do it and then you are okay, you are done for. So this one to find an f inverse of 3 pi over 2 is equal to pi on 2. So you are being asked to find the derivative of the inverse at 3 pi on 2. So if you want to use the formula, so this time you have to find, if you want to use the formula, you have to first of all find the derivative of f of x, which will give you negative sine x plus 3. And you realize that you have to check whether the x value lies between -1 and 1. Because we are saying that sine should lie between -1 and 1. So if it lies between it, then you proceed and then you come and find for the, what is this? You come and put it in where we had, the question is asking us to find the derivative of f inverse at x is equal to 3 pi on 2, and we were given that to be pi over 2. So when you state your formula, the f prime, that is the inverse, that is the f inverse, you put it back as pi on 2, and we know that f prime is sine x plus 3. So whenever you see x, you put pi on 3 there. So when you solve it correctly, you are going to get 1 over 2. I believe we all have the slides. Do we have the slides?
No, madam.
Hey, you don't have the slides. How is that possible?
Yes.
You don't have the slides. I want to finish this one. All these things, they're not difficult. So the remain
Madam Ade Janja, the mind is suffering. The mind
is
is
start.
suffering a lot.
I know. So
Madam, they are
we
the
would,
KM
we
corner.
would
I
end
dream a break.
on
Madam,
we
let's
will
postpone.
let me finish talking. Relax. Let me finish talking. We will end on this page. So the next time you meet Madam, you continue from page 40. That is inverse functions, basic properties. Are we okay? So so far, is there any question anyone wants to ask? Any clarity somewhere? anything that I said you don't understand. All these things, they are what we were talking about. How to differentiate exponential functions. It's like they are just repeating them. They are just repeating them. That's all. They are just even repeating all these things. Please, are you seeing what I'm trying to say? They are just repeating them. Because this
Hello.
side, hi,
Okay.
hello,
Yes, madam.
hello, yes.
Madam, this one there is a humble request. In fact, this course, I don't know how to put this, but a bit
Madam,
of.
once Jackson is okay,
I'm
we are
just
supposed to
pleading.
understand. I
If
think
we have some
Jackson wants
past
to
questions
explain
That
available, you
everything
can
better
put
to
them
us.
to us, so we start learning
Jackson,
it
why
along
deny?
with the slide.
so that is what I'm saying, that I'm not part of the page. So even if I have it, I don't know how
So,
to
madam, let the
send it.
course rep so that some of the
So
questions you have
by
not seen them before. You can't solve. So the
but
course
please,
of maybe my
I
contact to
want
say
you
if you
to
have
look
question.
at, you don't worry. Please, hello.
Yeah.
Relax for me, okay. I would get, if I'll put my number in messages or something so that he can text me. But I want us to do something quickly because the derivative, these things, I've spoken about it.
Okay.
The derivative of e to the power x, I've spoken about it.
Mm.
This, I've spoken about it. But I don't know, since, because that's the only thing left. And that was what we have been solving earlier. So I don't know if we are okay, because all these sides, if you looked at them. So it is just going to be a repetition of everything that I've been saying earlier on. Please, do you get what I'm trying to say?
Yes,
Yeah,
madam.
okay.
So it's like the remaining, I think it's of it, 10 pages. They are just repeating all that we did earlier, all that we are doing earlier. The formula when it is at a point, or the natural log, we've already said it. You see, they've repeated it again here, and then all that. So I would drop. So these are some try questions. You can. So let's quickly take a screenshot of this. Let us all take a screenshot of this so that at our leisure or free times, I'm pleading that we should solve them. Yes, you try solving them, and then I believe that will be okay. So please, have you done a screenshot? Have you taken
Yeah,
a
yeah.
screenshot? All right. So,
Yes.
Madam, please
So,
drop
uh,
your number so that if you don't
Madam,
understand,
how can we
so
get a slides?
and that was what I was saying, that I would
Madam, please,
uh,
I've sent you an invite. Hello.
invite. How?
Yes, WhatsApp group, the group we're talking about. So I've sent you an invite to join it for us.
You have my contacts.
Yes.
Justina. Okay.
Yes.
All right. So, I would send the slides for.
And the past question.
I'll send the slides for what we did, the first two things we did today, everything, so that we can go through it, and then if there is any problems, I am just a DM away. I am just a DM away. So I will join the page, and then I'll put the um, slides there, and I'll go through my documents to find the past questions for you too, so that you can have access and then be solving the
Thank you so
example.
much. The past question can
Please,
be
on this note,
necessary.
does anyone have any questions or anything that you want me to?
Jackson, any question?
No question. Thank you, madam.
Okay. So thank you
God
very
bless
much
you.
for your
Thank
time.
you.
I'm grateful
Thank you too,
for the
madam.
opportunity.
Thank you. God bless you.
We pray
Madam,
that
our
you
voice would
continue to
our
lose you.
Come
We, we,
again.
pray, we pray you
me so
continue
voice
to
would
lose
our
you because of your voice.
Oh, but that's a baby. My brembo.
Madam,
Oh,
where
Thank
there
God
is
for
about
you.
personal studies.
With a touch of
Now the
fancy, with a touch of fancy, my bro. Oh, Merazil.
Madam, I need one-on-one classes.
Hey, one-on-one classes thing.
Madam, me too, 1 or 2 classes.
One on
Hey,
two,
good.
one on two
Oliver,
here.
hey, Oliver.
Madam, me too, 1 and 2 classes. So. How much I go
Martin,
pay?
Basic,
please
sir.
let me join your group first, and then we can proceed. Right? I want to take some water and
Madam,
then
please, can I get
Enyo,
your number?
I'll join the page. So when I join, you see my contact.
All right.
All
Madam, please,
right.
what time can we call you?
Come again. Hey, you people, please. I have an invigilation in the next 40 minutes. So I have to rush. So please, thank you for your time. I'll join the page and
Have a
make sure
nice day. Have a nice day.
I send the slides to you and probably the past question. So do have a lovely evening and have a lovely week to ahead. Thank you very much.
Madam, the question is, when can we call you in case maybe you are having a challenge with, our studies?
Um, hmm. The daytime will be fine. Yes. During the day will be fine. Thank
Exactly.
you. So please, that is it for today. Bye bye.
With the French, the workers say, au revoir.
Oliver, nye na minim sɛ saa na ɔteɛ o. Minimum more than 5 years, more than 6 years koraa. Minim sɛ say na ɔteɛ.
Senior, don't tell me it's called Oliver
Oliver,
online, though. They are still recording.